Okay, Chapter 5, Lesson 2. This is fractions and decimals. So let's start off with converting a fraction into a decimal. Let's say we have something like 5/8. Well, keep in mind that the fraction bar right here is the exact same as a division symbol. So since it's saying divide, then divide. So we're doing 5 divided by 8. Okay, the 8 goes on the outside because he's second in line. He's the divisor. 5 goes inside the funhouse because he's first in line. And I did my long division here. I got really excited. I was going to write this out, but I just couldn't stop. I wanted to do the math really, really bad. So I got 625 thousandths. So 5/8 is 0.625. Now notice how this came to an end. There was a remainder of 0. Well, that means that this decimal has a special name. It's called the terminating decimal. Decimals that do not continue on forever. So when you're dividing, like we did above, okay, the remainder is going to be 0. Let's do some more examples. So if we had 1/4, 1/4, we'd be doing 1 divided by 4. So it'd be 4 on the outside, 1 on the inside. Bring up your decimal point. 4 goes into 10 twice, with 2 remaining. Add a 0, and then 4 goes into 25 times. So the decimal of 1/4 is 25 hundredths, or 0.25. Let's keep going. What if we had 1 7/8? 1 7/8. Well, how would we convert that to a decimal? Well, let's first forget about the 1 for a second. Let's just convert 7/8 into a decimal, because that 1 is a whole 1. So worry about the 7/8 because it's going to be 1 point something. So 7 divided into 8. So 7 goes inside the funhouse. 8 goes on the outside. 8 goes into 70 8 times, with 6 remaining. We're going to bring down a 0. 8 goes into 60 7 times, with 4 remaining. Bring down a 0. And 8 goes into 40 5 times, with nothing remaining. Cool. So 0.875. Now since it's 1 and 7/8, we have a 1 and 875,000, so 1.875. Cool. Go ahead and try these two on your own paper. Try 3 3/10, and then 3/5. Divide and see what you get. Now, for number 5, let's do this one. We're doing 2 divided by 3. Okay. So 3's on the outside, 2's on the inside. 3 goes into 20 6 times with 2 remaining. Wait a second. 3 goes into 20 6 times with 2 remaining. Bring down another 0. 3 goes into 20. Hey, wait a second. I think this is going to go on forever. And it definitely is. So when you get a number that goes on forever, what you do to write this as a decimal is you write 0.6, and since 6 is the digit that keeps repeating, we put a bar over it to indicate that that number is going to repeat on forever. So this is a repeating decimal. Okay? It's a repeating decimal. And repeating decimals, I'll go ahead and write that down here. They have a digit after the decimal place, or block of digits that repeat forever. Okay, so those are repeating decimals. Let's try another one, like 15/11. So we're doing 15 divided by 11. So 15 goes in the funhouse. 11's on the outside. 11 goes into 15 one time, with 4 remaining. So we'll bring down the 0. 11 goes into 43 times, with 7 remaining. Bring down another 0. 11 goes into 76 times, with 4 remaining. Hey, wait a second. 11 goes into 40, wait a minute, 3 times, with 7 you should be like, whoa, Mr. Bohoric, you're running around in circles here. And I am. That's because the block of digits that's repeating is 3 and 6. So how would we write this? 1.36. You put a bar over the block of digits that repeats. Cool. Now, let's go vice versa. Decimals to fractions. In order to convert a decimal to a fraction, just say it correctly. 0.4, the real way to say this. Okay, we say 0.4 to save on time, really. It's not really correct to say it that way. But we're supposed to say 4/10. Well, doesn't that sound like something to you? 4/10. 4 over 10. Well, then, we're supposed to simplify. Anytime we have fractions, we gotta simplify. So, we have 4 over 10 to simplify. Divide the top and bottom by the GCF, which is 2. So 2/5. Booyah. Let's do some more examples. Let's say these correctly and then simplify. So negative 0.375, 375 thousandths. So that's 375 over 1,000. Now, right away, I'm sitting here going, first off, it's negative. Second off, that is a huge number. It's a very, very big number. Okay, I'm looking at it, and I don't know what the GCF is right off the top of my head. There's no way. So I'm going to say 25. I know 25 goes into both of those numbers, so I'm going to go with that. So the first top part, 375 divided by 25, if you think about it for a second, that should be 15. And now the bottom part, 1,000 divided by 25, think about it for a second. Yep, it's 40. So 15 over 40. That can be simplified even more. Okay, so I think 5 goes into both of those. So let's do divide by 5, divide by 5. So 3 over 8. And that cannot be simplified. So make sure we don't forget, it's supposed to be negative. So negative 3 over 8. Cool, let's do another one. 1 and 75 hundredths. 1 and 75 hundredths. Notice how I said that correctly, and now I'm almost done. Let's simplify the fractional part. So 25 goes into 75 3 times, and 25 goes into 100 4 times, so 1 and 3/4. Groovy. Now let's do 0.7 repeat. Whoa, what? 0.7 repeating? Well, great. Well, this isn't as easy as saying 7/10, because 7/10 doesn't repeat. This is saying 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, forever. Well, there's a trick. This is not in the textbook, so this is exclusive Mr. Bohoric content. Actually, not really, since it's math, and math's been around forever, so yeah. Anyways, there's a trick. Basically, take the digit that repeats and place it over a 9. 7 over 9. Bada bing, bada boom. That's it. So the trick is, put the repeating digit over a 9. Okay, if there's more than one repeating digit, you put it over the number of digits that repeat. So you have to put, if there's 2 digits that repeat, like a 3, 6, 3, 6, like that other example we did. Let's see, where is that? 3, 6, 3, 6, 3, 6. And then it would be over 2 9s, since 2 digits repeat. Let's do a couple more examples. So we have 0.53 repeating. There's 2 numbers that repeat, a 5 and a 3. Well, 5, 3, 2 numbers that are repeating, so 2 9s. Hooray, we're done. Yeah, guaranteed that does not simplify. Now, okay, 3 numbers repeating. Well, 2, 1, 3. Hey, guess what? Over 1, no, 1. 9, 9, or 3 9s. So 2, 1, 3, over 999. But that actually simplifies. Okay, you thought I was done because I circled it. No, I tricked you. Okay, it simplifies. 3 goes into both of those. 3 goes in the top 71 times. 3 goes in the bottom 333 times. That's the answer. Because we always simplify. 71 over 333. Now, here's a random picture of SpongeBob. Fractions. Hooray! Alright, and that was fractions and decimals.